Hello, calculus. Here's part 2. We've got another lovely graph with an equation. This is a square root function, but it's also got that x term in there, which makes it a little wonky, right? Not a perfect little square root. Based on this graph, at what values does the graph of g of x have a horizontal tangent? A horizontal tangent line looks like it occurs about here, but we want to prove that analytically with algebra, right? So in order to prove that, we want to find, first of all, what is the slope of a horizontal tangent line? Well, this piece here, the slope of a horizontal tangent line is 0. So I want to know, remember the derivative is the slope of the tangent line. I want to know where is the derivative equal to 0. That's what they're asking me to find. So first, here's g of x. We're going to write it in polynomial form. In other words, where x has exponents, right? So this would be 2 times x to the 1/2 power minus x plus 2. For the derivative, I've got g prime of x. 1/2 times 2 is 1. X to the 1/2 minus 1. You have half a pi, and I come take a whole pi from you. Now you have negative half of a pi. All right, and what's the derivative of negative x? Remember, if it's to the 1 power, this is 1 times negative 1, which is negative 1. X to the 1 minus 1, this becomes 0, so this just is 1, right? Derivative of just the x power is just the coefficient out front. We don't write the 1 there, but that's negative 1. And then derivative of a constant is 0. So this is our derivative. I'm going to go ahead and put it back into square root form for our analysis later. All right, we want to know, where is this guy equal to 0? We think it's here at 1. So if I plug in 1, what should I get back? I should get back 0, because that's where we think the tangent line is 0. So 1 over the square root of 1 minus 1. Square root of 1 is 1. 1 divided by 1 is 1. 1 minus 1 is 0, so we were right. All right, so since g prime of 1 is equal to 0, then g of x has a horizontal tangent at x equals 1. We proved that we were correct. All right, number 6 asks us, on what intervals is the derivative, is g prime of x less than 0? So where is the derivative negative? Well, remember, our derivative is going to be negative. The slope of the tangent lines are going to be negative when g of x is decreasing. So we're talking about from 1 to, where is this guy going off to? Infinity. So the derivative of x is less than 0 on the interval 1 to infinity. Why? Because g of x is decreasing on that interval, right? All right. 6 asks, when is it negative? 7 asks, on what interval or intervals is the derivative positive? Well, the derivative is positive when my function itself is increasing. So just this little piece here is where the function is increasing. So that's between 0 and 1. So g prime of x is greater than 0 on the interval 0 to 1, because g of x is increasing on that interval. All right, for what values of x is the slope of the tangent line equal to 2? So when I say slope of the tangent line, you say derivative. So we want to know, when is the derivative equal to 2? Well, we're going to come back up here. What do we get for our derivative? Our derivative is 1 over the square root of x minus 1. So I want to know, when is 1 over the square root of x minus 1 equal to 2? And now we're going to solve this guy for x. Moving the 1 over, I've got 1 over the square root of x is equal to 2 plus 1, which is 3. I need to get the square root of x out of the denominator. So I get 1 is equal to 3 square root of x. Divide by 3. 1/3 is equal to the square root of x. Square both sides to get rid of that square, and x is equal to 1 over 9. And that's when the slope of the tangent line, the derivative, is equal to 2. And then it says find an equation of the tangent line drawn to the graph of g of x when x is equal to 4. Then draw the tangent line on the grid above. Well, we said at x equals 4, what's happening on our graph? We're decreasing, right? So we should have some sort of negative slope here. Here is our derivative. We need two things to write our tangent line. We need a point on the tangent line and the slope of the tangent line. The point on the tangent line, we could find g of 4. And if they asked us to, I guess in class I said you could look at the graph, and I think you still could, but if you actually had to prove it, you're trying to find g of 4. Well, g of 4 is equal to 2, or if I plug in 4 here, we should see that it's equal to 2. So the point on the tangent line is 4, 2. And then what is the slope of tangent line at 4? I don't think we found that anywhere. So g prime, the slope of the tangent line at 4, is 1 over the square root of 4 minus 1. Just using my derivative, right? That we found earlier. So this is 1/2 minus 1, which would be minus 1/2. So I got y minus 2 is equal to negative 1/2 times x minus 4. You guys have got to be able to write a tangent line really fast, just like we're doing right now. All right, come back, and we're going to do that problem we did today in class where we've got a table. And again, 4 and 5 are going to be the new information for tonight.